Well, welcome to Monday's math class. Sorry I'm missing out on this. Today we are going to be focusing in on writing ratios and proportions. So that's what we're going to work on. You guys have a warm up, so we are going to pause the video now so that you can finish it up. All right, everybody should have finished the warm up. Hopefully it didn't take too much of your time. Remember, the faster you are on the warm up, the more time you have for classwork. First one, I'm going to move a little bit of things around just so I have some room. The first thing that we're looking at is solving the equation. So when we are solving the equation, your goal here is to try to get just the x value. For some of us, we might be able to see numbers really fast or we're using a calculator. The big thing here, I need you to be able to show me the work. I don't require that you stake down the problem every time. I do require your work. So in order to get 1x here, we're going to divide by 8. What you do to one side, you have to do to the other. In that step alone, just glancing at this, hopefully your math skills are good enough to know that you are going to have a decimal for an answer, if not a fraction. I don't care which one you give to me. You needed to take 26 and divide it by 8. It does not go evenly. You should hopefully have on your papers 3.25 or 3 1/4. If you have it as an improper, that's fine as well. Even so, you just need to be able to tell me what x is. If you left it as a fraction, so let's say that you saw that this went to 1 and then the other side you're saying, all right, well, 26 is not evenly divisible, you might have taken that 26 over 8 and then just reduced it, which I am absolutely fine with. Again, remember that I told you that improper fractions are going to be the best moving forward, so you just needed to come up with a value that will go into both. 2 would go into both, so if I divide the top by 2, I get 13. If I divide the bottom by 2, I get 4. Again, if you divide 13 divided by 4, it's going to give you that same 3.25. So as long as you had something for that, that's great. The second one, it says, what is the ratio of stars to hearts? We haven't talked about ratios yet in this class. This is today's lesson. So I'm hoping that you came up with something. Trying is key in this class. Your ratio of stars to hearts could be written in lots of ways. As long as you have something, that's great. As long as you know what a star is and a heart is, that's great. So let's see how we do here. It wants stars first. So if you're an individual that labeled the hearts first, you have this somewhat wrong. Hopefully we have something. So ratio of stars to hearts, there's 1, 2, 3, 4, 5 stars. 2, some people write it with the colon, so it's 5 stars to 3 hearts. In this class, I'm okay with that. I personally would probably write it this way. That's just because fractions are going to show up again and again and again and again, and I can manipulate this. This top one is tough to manipulate. You have to use a little bit different thinking. So what is a ratio? Hopefully we came up with one of these. We are going to look at ratios and proportions today. So first, you don't need to write this down. You're paying attention. A ratio uses division to compare two quantities. You can write ratios of two quantities of A and B where B is not equal to 0 in 3 ways. The first is using the word to, so you could use A to B. The second is the colon, and we just talked about that one on the previous slide. And then the last one, and honestly the one that I prefer, is going to be this one. That might be new to you. The majority of us probably wrote down this one. Realistically, I'm hoping to see more of that one. So as we move forward, we are trying to focus more on the A over B as a fraction, and the reason that we're doing that is because we can manipulate this really quick. These other ones, not so much. So each ratio is going to be read as the ratio of A to B. So the ratio of A to B, ratio of A to B, ratio of A to B. There is value in the fact that B cannot be equal to 0. The reason that B cannot be equal to 0 is because if B was 0, you don't see it here so much or here so much. It's this one that shows up the rule. We're dividing, and you cannot divide by 0. So B cannot be 0. So I'm repeating this. B is not allowed to be 0 because we cannot divide by 0. So remember that B cannot be 0 in a ratio. Okay. We'll come back to this when we get to our examples, but like units need to be across from like units. So basically, if I was comparing girls to boys in this class, if I was, and this kind of goes pretty easy, if I was comparing girls to boys in this class, and then I was comparing girls to boys in another class, my ratio has to be lined up where it's girls to boys. Otherwise, it doesn't make any sense. In the same fact, if we said just talking about eye color, if we were talking about green eyes versus blue eyes in our class, it wouldn't make much sense to compare that to blue eyes and green eyes in the other class, because then you'd be cross comparing, and we don't want that. So basically what that's stating is if you're using this form, you have to compare straight across. So here's example number 1. A volleyball team plays 14 home matches and 10 away matches. Find the ratio of home matches to away matches. Make sure we read carefully. The volleyball team plays 14 home matches and 10 away matches. So in this one, we're going to have 14, because it asks for the home matches first, to 10. 14 home matches, 10 away matches. That's the first. B says find the ratio of home matches to all matches. It does not state all matches up here directly. You have to go, okay, well, if I play 14 at home and 10 of them are away, altogether I came up with 24 games. So it wants the ratio of home matches, 14, to the total matches, or all of the matches, and all of the matches was 24. Now, like most math, these could both be simplified. You could reduce them down, but it almost makes sense just to leave them when we're comparing these two things, because if I reduce it, now all of a sudden it's no longer going to pertain to the story that's being told. If we were looking to create it in a ratio in simplest form, then most definitely we would reduce. Okay, solving this equation. So I want you to look at this equation for just a second. We're not going to pause the video, but we're taking some number and we are dividing by 7. That gives me 4. If you're good with your numbers, we could come up with the fact that this number has to be 28, because 28 divided by 7 is, in fact, 4. The issue that we run into with that is what happens when the numbers get nasty. When the numbers are nasty, you might not be able to see it. So today I'm going to teach you ways to solve the nastier problems. For example, here's a proportion. We have two ratios, y over 4, or y to 4, and 15 over 20, or 15 to 20. We're stating that they're equivalent. Again, equivalent, remember, is that they are equal. We're going to solve this. Well, if you try to solve it the same way that you did the last one, where maybe you just see it, it gets difficult. You might not just see it. Now, some students are going to. Understand you might see it. I need to see work. So when we are solving proportions, the easiest way to solve proportions is to cross multiply. Cross multiplying is taking the things that are across from one another, not straight across, but at a diagonal, and cross multiplying them. The equal sign that is there will get brought straight down. Now, this is only true when we are comparing two equivalent fractions. So the equal sign has to be there. If this equal sign is not there, then we have an issue. So in this case, we are equal. So we're going to bring the equal sign down. I'm going to cross multiply. And I don't care which way you cross multiply first. I personally am a creature of habit, and I will always multiply the variable first. So that means I'm multiplying this way first. So that's 20 times y. The first ones I'm going to write down. Eventually I won't, just because we're going to get lazier as the day goes on. So I'm going to multiply 20 times y. The next thing I'm going to multiply is going to be going the other way, so that's that 4 times 15. Again, the first ones I'm writing down. In the future you will not, because you're going to have the original problem written down. So on the left hand side I get 20y. Equals, then I'm taking 4 times 15. That gives me 60. From there, I'm just solving. So I'm going to divide both sides by 20. When I divide both sides by 20, I see that y is equal to 3. So your answer there, the y value has to equal 3. So 3 over 4 is equal to 15 over 20. Now, I need the work. Some of these you're going to be able to see. Some of you might have been able to conclude that that was 3 without doing any work on your paper. I need to see the work. So if you did it another way, you have to show me the work. Realistically, what I'm hoping for today is that we learn to cross multiply to solve. This is, again, only true when it is an equal sign. Notice if we go back, it would actually work for this one. If we cross multiply to solve, you just have to make it to where we can. This would be over 1. 1 times x. Cross multiplying 1 times x is just x. If I cross multiply the other way, I would take 7 times 4, and 7 times 4 is 28. So 1x would equal 28, or just x equals 28. Okay, number 8, same thing. before we get going too crazy here. Number 8, I will give as an example, 4 over 1 equals z over 16. Again, I would always start with the variable, so z times 16, or excuse me, z times 1. Z times 1 is just z. The equal sign must come down, and then I'm multiplying 4 times 16. 4 times 16 then, the z is coming down. Again, that was 1 times z, and I maybe should have wrote that down because it's 1 times z. And then 4 times 16 gives you 64. Some of the problems will solve themselves. Notice this problem, as soon as I multiplied, z times 1 is z, 4 times 16 is 64. I have all of that solved immediately. It's not like this one where I had to do extra work to solve it down. So we are going to pause the video now. Excuse me, sorry, hopefully you didn't pause that. We're going to pause the video as soon as I click this, finish these up, try to take about 3 minutes to finish it. If you finish quicker than that, you can start the video. Okay, if we're back, or you paused it and had to unpause it and move things around. If not, hopefully we didn't mess up too much. I apologize. This is what our work should look like for both of those. You're self-grading. This is what we're hoping for. That was kind of a mess up on my part. Hopefully we had that figured out. If we paused it with the answers up there, hopefully they made sense. Again, number 10, you needed to cross multiply. You could start with the 2 times 36. I would start with the 12 times x. 12 times x is 12x. 36 times 2 gives you 72. That's what's happening right here. And then to get x by itself, I'm dividing both sides by 12, so x equals 6. Similarly, on number 12, I would start with k and 18. Notice the k and the x are on different sides. On the number 12, the variable's on the left. On number 10, the variable's on the right. I don't care where it's at, and I don't care how you solve it. Me personally, I will always multiply by the variable first. Eventually, we're going to get problems where the variables are on both sides, so then it doesn't matter. Where we are right now, I'm telling you, this is my own way. It is not the only way. 18 times k is 18k. 9 times 10 is 90. Divide both sides by 18. K equals 5. Sorry for that mess up with the pause. All right. How many cups of flour would it take to make 15 pancakes? So this is the question. They give you this stuff. Remember that word problems we answer with words. We're looking for cups of flour, 15 pancakes. The first thing that I would recommend that you do is just label. I'm going flour to pancakes. If that's how I set it up, flour to pancakes, then that's what my proportion should look like. In this case, I want 15 pancakes. So 15 can't go on top. I about just messed up there. I want 15 pancakes. I set it up to have pancakes here. So 15 pancakes. I want cups of flour. That's my question. It says how many cups of flour. I don't know how many cups of flour, and you could use the C here if you wanted. And then this other portion, I'm going to just use the recipe. The recipe calls for 1 cup of flour, 1 cup of flour, and 1 cup of flour yields 9 pancakes. So this is going to be a 9. Now, again, you wouldn't have to use F. A lot of times students use X. X is one of the most common variables out there. I don't care what you use. Again, for me, I'm going to multiply f times 9 first. If I multiply f and 9 first, I get 9f. I wouldn't write it as f9. Remember that that's for Battleship. So 9f, that would be my first. And then multiplying the other way, I get equals 15, because 15 times 1 is just 15. Now remember, we're trying to find total cups of flour. We're going to divide both sides by 9 to get 1 cup of flour. When I divide both sides by 9, I get f on the left. On the right hand side, I'm taking 15 divided by 9, and I get 1.6 repeating for cups of flour. Now, that might throw you off a little bit, because I don't know how many of you have ever taken 0.6 of a cup before. That doesn't make sense. When it talks about cups, you're going to have to start making some conversions. So that means maybe don't use a decimal, because we don't use decimals when we start measuring things. So if that is how you had your answer, then we're going to say that that one's wrong, hence the reason that it's in red. Instead, take your flour, use 15 over 9, embrace the fact that fractions are going to show up a lot, and then start making changes. For example, what number goes into both 15 and 9? Hopefully you came up with 3. So the amount of flour is equal to, if I divide the top number by 3, I get 5. If I divide the bottom number by 3, I get 3, 5/3. 3 goes into 5 one whole time, with 2 parts remaining out of 3, which kind of makes sense. You had 1.6 earlier, 2 divided by 3 is 0.6 repeating. This makes sense with cooking. Do not give me 0.6 for cooking. You don't know what 0.6 is. I don't know what 0.6 is. 2/3 of a cup, I could put that in. So notice how we set this up. We went flour for pancakes. Same exact problem. Typed in 9, 1, 15x. Notice 9 is the pancakes. So this thing went pancakes to cups of flour. Same exact thing. The big thing to recognize here is we're looking at this pancakes, pancakes, pancakes. 15 pancakes. 9 went with pancakes. All the pancakes are on the top versus this last one, we had pancakes on the bottom, pancakes on the bottom, pancakes on the bottom. I don't care how you set it up. So whatever your original setup is going to look like, you just need to carry that setup all the way through. So if it's pancakes on top, then it's pancakes on top. When we solve this, we still get the same thing. You could ask yourself, all right, how do I undo dividing by x? Just cross multiply to solve. 9 times x is 9x. 1 times 15 is 15. When we get back to that, then we're just dividing it out. If it doesn't divide nicely and it gives you 1.6 repeating as an answer, you don't have 0.6 of a cup. 0.6 would work when we're dealing with money, not for cups. So make sure you answer the problem appropriately. Last concept to talk about, cross multiplying. Again, this is what we just did over those last couple problems. This is given just as kind of a thing for notes. Again, B can't be 0 in this case, and neither could D, but that's just because they set up two proportions, and it's going back with that exact same rule that we learned earlier. The bottom number cannot be 0. If the bottom number is 0, you're dividing by 0, and that's not possible. Same thing here. I'm not going to waste your time with working these out, because I feel like we can do it. Homework. Homework today is going to be 0.7. Ratio and proportions worksheet, and your guest teacher, will tell you which problems you do not have to do for being in class today. Thank you.